Assalamualaikum and good morning and welcome to our top management meeting, and this meeting will be presented by Group 9 Team Lajak Kuruih on 2nd July 2020. First of all, good morning to all board director, top management, and especially our lecturer Dr. Zarina binti Muhammad Khalid and all friends. My name is Amir Ashraf bin Zaid, and others to name is my friend will be presented to you in this meeting. Okay, I will define first our background. Lajak Kuruih, Lajak Laku is a manufacturer that produce health supplement diet tablet called Lajak Kuruih. The company produce at least 15 type of Lajak Kuruih tablet with different health property, which is we were assigned to do research on Lajak Kuruih data. These tablets are produced at the Lajak Laku factory and are popular among Lajak Laku consumer. In tablet manufacturing operation, common problem encountered include fluctuation in tablet weight and inconsistent tablet hardness. These problems are usually due to uneven powder flow into the die due to poor powder flow properties, uneven feeder material into the tablet process, malfunction of the pressing machine, and many more. It is important to ensure tablet uniformity at every batch produced so that further corrective measure can be taken at the shop floor. And this problem we will present to you how we define. First of all, I define to you what the problem, and data that we get will be measured and do analysis. Okay, next. Before we start, I have summarized the keynote that the meeting will be going. That has 5 keynote, and I will present to you the summarized data and goodness of fit analysis. Shukri will be present you about ANOVA analysis, and Izzat will be present to you about linear regression analysis. Okay, this data will we measure all the data that we get from production, and the sample size of data we get is total 200, and we already divided into the 3, which is morning, evening, and night. And from this table and this pie chart show that evening has the highest amount of production, while in the morning has the lowest. Okay, we summarize the sum of weight, where based on sum of weight data and graph show that evening has highest production while on morning has the lowest production. Average of weight, based on average weight data collection and graph show that at evening morning event has the highest average weight production, while from the evening to night the numbers goes down. Average relative data, evening shift recorded the highest average relative density, while night shift record lowest average relative density. Average tensile strength, the average tensile strength per shift show morning and evening shift record same amount of tensile strength, while the result goes down on night shift. Okay, from 3 weight relative density and tensile strength, we already divided the sample into range where we can get the frequency, and you can see from weight range, the frequency that has the highest amount at 350 to 349, and at relative density, the highest frequency show that at the range 88 to 88.9, and at tensile strength the highest frequency at 7.1 to 7.19, and this is overall from the data. We conclude into average weight, average relative density, average tensile strength. This all data is important to do our next analysis, where first we define, and now we measure all the data, we summarize the data to do the analysis. Okay, first analysis, goodness of fit analysis, where you can see on weight, we already put it into the range, and the frequency we collect from slide before this, the frequency. So the hypothesis, HO lajak laku table follow the distribution, H1 lajak laku table not follow or reject the distribution. So this hypothesis we will see if the result, finished result, follow which hypothesis, if it follow or reject the distribution. Okay, the analysis on this table, where we already summarize the data, the probability, the frequency, the x square test on my right side, OI minus EI square divided by EI. This is the final result for x square test, and we will sum all of these and see if it reject or follow the test. Okay, decision. Since x square test 2.8776, sum of all the x square tests from every range is lowest than x square 0.055 is equal to 11.0705, that in insufficient evidence to reject HO. So the conclusion from goodness of fit analysis, we can conclude that at 0.05 or 5% level significant, there is significant evidence that the weight of standard tablets Lajak Laku tablet produced in December 2020, regardless of shift, follow normal distribution with mean 350 mg and standard deviation 14 milligram. Okay, that's all from me, and I will pass to my friends Shukri for next analysis. Thank you.
Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shukri and I am from Group 9. We'll be presenting about Pil Lajak Kuruih I. So my name is Muhammad Shukri bin Muhammad Fauzi and this is my group mate. So this is the background roughly as been briefed by my group mate Amir, and also the sample size, sum of weight, average of weight, average of relative density, tensile strength, and also the data given by our lecture. So my part is to explain part C, that is comment on whether there is any significance difference between tablet weight from the different shift. So in this part, we will use one-way ANOVA. So basically, the one-way ANOVA analysis of variance specifically allow us to compare several group of observation, all of which are independently but possibly with a different mean for each group. So a test of great importance is whether or not all the means are equal. So the output of each the observation may be written as y ij equal to mu I plus sum of ij. So this is the one way ANOVA using Excel. So this is the summary. So this is the summary of ANOVA single factor, summary of the week, morning, evening, and night. So the sum of the week will be in the morning will be 20,102.09 milligram, and the average we will get 6,700.9.696667, and the variance we will get the 13279323722. For evening, we have the sum of 27,404.88, and the average will be 9,134.96. So the variance will be 247737.9. And the night for the night shift, we will get the sum of weight is 22,779.75. So the average will be 7593.25. But the variance is 170821408.3. So this is the ANOVA analysis. So the source of variation will be between groups and within groups. For between groups, the SS will be 9099159.153. For the difference is 2, and the MS will be 4549579.506. For the F, we will get 0.024755.015, and P value that I use is 0.975,648, and the F crit is will be 5.143253. So the total of the SS will be 1111804116, and the difference between this is 8. So I will show you for the Excel process. So this is the Excel process. For my part is part C, so this is how it is done. And that's all for me. Thank you.
Okay, hello everyone, my name is Izzat. Okay, as we look at Lajak Kuruih's statistical observation, tablet harness can be represented by its relative density and tensile strength. Studies have indicated that the tensile strength depend on the relative density regardless the production shift. Recently, a batch was found to produce a cluster of tablets that show low relative density value of 68%, 74.3%, and 82%. Based on the current data, predict what is the prediction of the tensile strength. Also, the comment the efficacy of the model and whether the underlying assumptions are satisfied. From this statement, we can find the prediction of the tensile strength by using linear regression analysis from Microsoft Excel. This analysis is to obtain predicted response value by using simple linear regression statistical analysis method. So,
The definition of simple linear regression (SLR) is equation relate one single dependent variable to one single independent variable linearly, which is straight line. To find the specific predicted value of response y, we can use equation y is equal to beta x plus alpha, where y is the predicted value of response, b is the coefficient of the slope value, x is predicted value, and alpha is the coefficient of intersection value. By referring to the statistical table and regression analysis from Excel, we can obtain the scatter plot graph, regression statistic table, and coefficient table. As we go detail into the scatter plot graph, the x-axis represent the relative density, meanwhile y-axis represent tensile strength. We can see that the gray dotted point in this graph is actual tensile strength, and the straight red line is predicted tensile strength. Next, we can see the regression statistic table that show multiplier R is a correlation value between relative density and tensile strength, which is equal to 0.839. Meanwhile, the R square or the adjusted R square is a determination coefficient value, which means relative density illuminate tensile strength at 0.7 or 70%. Moving to the coefficient table, the intercept value, which is C, and the standard estimation error is 31.37%. Also, the gradient value M, the standard estimation error is 0.356%. Intercept coefficient value are at 0.2779, and this is value of alpha. Relative density coefficient value are at 0.0775, and this is value of beta. The coefficient value that obtained from Excel analysis straight away tell us that estimated regression equation is y equal to 0.0775x plus 0.2779. So, prediction of tensile strength. We can obtain the tensile strength value from the estimated regression linear equation by simply inserting value of relative density into the equation. For relative density at 68%, the tensile strength will be y equal to 0.0775 times by 68, then plus 0.2779, which is equal to 5.5479 megapascal. For relative density at 74.3%, the tensile strength will be 6.0362 megapascal, and at 82%, tensile strength will be 6.6329 megapascal. From the analysis, we can conclude that by using test result of the tensile strength from the relative density, we can use linear regression model with up to 95% confidence level. Thank you.